and welcome to another video. In this video, we're going to be working on longest palindromic substring. So in this problem, you're given a string S, and you want to return the longest palindromic substring in S. So for a string like BABAD, make this bigger. The longest palindromic substring would probably be like BAB or something, or ABA, right? And so you have a 3-character substring. And then for a string like CBBD, actually it's bigger, the longest palindromic substring here is BB. So essentially we need to figure out how to do this. And you could try to like the brute force method would be starting at a character and then continuing on and trying to build from every single character. But that's basically going to be like you'd have like a starting character and an ending character. And you would try to build from there. So like you'd start with this character and you'd be like, okay, maybe it ends here. And then you check everything in the middle. Maybe it ends here, you check everything in the middle, and so on. And so the problem is like an n-cubed solution. So I'm going to show you how to do this in like a really convenient way that's not DP. And it works for all these palindromic, like longest palindrome or number of palindromes or all these things. So essentially the way it works is let's just get some word here. So we get a word like, I don't know, like whatever, I guess. Let's think of something. Let's say like consist. Actually, that wouldn't really work. But just take A's and B's or something. So let's say like A, B, B, A, B, B, A, B. Something like this, right? Okay. So you have a word like this, and we are trying to find the longest palindrome in here. And so the way this works is we're going to build from the center, and we're going to build out. And the longest word we're going to build is going to be our answer. And by from the center, I mean is every palindrome can either be odd or even. So if it's odd, that means the center is going to be a character. So like we'll just take like a B here, and this will be the center, and then we will build out like this and so on, right? Or it will be even, in which case we will start with 2 letters, like these two, and then we will build out and so on. And that's going to be our strategy, and then the longest one we build is going to be our answer. So let's kind of walk through what's going to happen here. So we're going to go index by index and try to build out. So like here, we will take an A, and we can't really build out anymore, right? So our result for now is going to be A. Then we're going to go to, then we're going to go to B. So if we go to B, I wonder how I can actually select this. There we go. So if we go to B, we are going to try to build out where B is the center, right? We're going to take the odd approach. So we're going to say, like, okay, well, with B is the center, how far can we build that? Well, we can't build this because this is not a palindrome. And it's very easy to check, right? So you just have 2 indices here. So you have a left and a right. For the odd, they start at a character, and then you just build out like left and right, and you just check, are the characters equal? If they are, let's build out. And so for B, the longest thing you could build is B. Now let's also check the even character that uses B. And so the way we're going to do that is we're going to take the 2 letters B and the letter to the left of it. So here, we're going to do something like this. And this is not a palindrome, so we're not going to consider that. So now we're going to try this B, and we're going to say, okay, we're going to build out from the middle. So our left and right start here. Let's try to build out. Okay, this is valid. This is valid. And then everything past this is out of bounds, right? Because there's nothing to the left. So we have a 5-letter word, A, B, 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 A. So we will save that now in our result. And now for this B, we're also going to try the even approach where we take 2 letters. So we're going to take B and the letter to the left, and we're going to build out that way, right? Every palindrome will be even here. So this is fine. Is this fine? No, it's not. So our longest word was 2. Okay, now we're going to go over here. We're going to try the odd. So this is fine, but we can't build that anymore because B won't equal A. And let's try the even. So we'll have these 2. This is fine, but then this would not be fine, so this is also 2. So far our best is this. Now we will start here. We will try to build out odd. Can't build out anymore, right? Because B does not equal A. Let's try even, the character and a character to the left. And you can either do the character and the character to the left or the character and the character to the right, either way, as long as you have all combinations of 2 characters next to each other to get all even palindromes. So this wouldn't work, so we're going to go to the next letter, and we're going to try to build out. So we're going to say A. This does not work, and let's try even. So this is fine. This is fine. So we have even. Can we build out more? Yes, we can. And that's pretty much it, right? Because now B does not equal A. So now we have BB, AA, BB. So we're going to change our answer to that now. So it's going to be BB, AA, BB is our longest so far. Yeah. And that was with this A and this A. Okay, so now we will go to this character, and we're going to try to build that oddly. And this is as far as we can go, because these two wouldn't be equal. Now let's try even. So this is already doesn't work. So there's nothing here. Now we're going to try to build here out odd. We can't. And let's try even. So the character and the character left. This is fine so far. This is fine so far. This is fine so far. And this is fine so far, right? So this whole thing is a palindrome. So it's going to be from here to the end, right? So BAAB, BAAB. That's a palindrome. BA. All right, it's actually BAB and then BAAB. So this whole thing right here. And obviously, now that we're scrolling through here, we're obviously not going to get anything better than that, right? Because I think to get that, we were on this character. So we can do the rest of it, but we're never going to get anything better than that. But we'll try A. We can try to build that oddly. We can't. We'll try even. This doesn't work. Then we'll try this A. We'll try odd. We can't because these two are not equal. We'll try even. So this is fine, but then we're out of room over here. So the best word we found is this BAAB, BAAB. And that's kind of the pattern. For the odd, our left index will be I, and our right index will be I as well, right? We're starting at a letter. And for the even, you can either do I and I plus 1 or I and I minus 1. So in my case, I'll do left equals I and right equals I minus 1. And you're essentially building up from the middle, and this is going to be an n squared solution because there are n possible starting locations. There's actually 2 n possible starting locations, right? For every letter, we have the left and the right are the letter, and then we also have the left and the right are the letter and the letter before, right? So there are 2n starting locations, and you build out from each of them, which will maximum take length n. So this is a 2n squared solution, which is an n squared solution, and that's not n cubed, and this will pass. So that's kind of how you do this, like number of palindromes or longest palindrome. And if you were asked number of palindromes, you would just start building out. And then every time you have a valid build, you will just add one to the result. So it's literally the same thing, but except here we just keep track of the biggest one, right? Max or count, the code is basically the same. Okay, and now that's what we're going to do this, and now we can code it up. So we're going to say, I think here, we don't have to check for an empty string, I believe. Let's just double check. Wait, I don't think we do. The string is, yes, we don't have to check for an empty string, so I don't need any of that. So we're going to make a function that we're going to use, and it's going to be called expand from center. That's essentially what we're doing, right? We're building up from the center of palindrome out. So we are going to say def expand from center. Actually, use this. Center, and it's going to take a left and a right, right? So we will say while left is greater than or equal to 0 and right is length s, and they are equal. Let's just keep trying to build them out, right? Let's just keep trying to expand them. And so our final solution here will be the left will be one too far, and the right will be 1 too far, right? Whenever you get an invalid solution, that won't work. So we're going to say left minus equals 1, right plus equals 1. And then what we want to return is, remember, these two locations will be like, for example, in this picture, like let's say we start here, our left and right are both here. So we'd have a left and a right. These are valid. Then we're going to try to go over here and we're going to say these are invalid. So our locations will actually be 1 too far. So then what we want to return is the one before that. So here we're going to return left plus 1, right, the one before that, and right minus 1. And that is basically going to be the function that's going to tell us the length of the word. And then instead of building out these palindromes, because that's going to be expensive, right, we don't want to keep like appending to a string, we're just going to record indices, and from indices we can figure out the length of it. And then if we have one with a bigger length, we're just going to store the left and the right index of it. And at the very end, if we have the left and the right index, then we can just get that substring. So we're going to say start, and as a default, we'll be at 0, 0, right, because this is always valid. Because if this is a string of length 1, a valid palindrome will just be the first letter. So we'll just let it start there, and then we'll see if we can find anything bigger. So for I in range length of s, we are going to try to build the odd ones first. So we'll say like left 1, right 1, Or we can even we need both of them, right? Actually, we could do it this way. So we could say left right equals expand from center, and then for the odd we want to give it the left and the right should be the index we're on, right? And then we can say if. So we'll get some left right here, right? We'll get these results, and we'll say if right minus left is greater than end minus start, meaning we have a longer string. Now let's just replace those. So we'll say start end equals left right. And then we do the same thing for the even. So we'll say left right equals expand from center I. And I guess we could use I plus 1, I minus 1, right? Either one works. So I guess we could say, yeah, I think either one works. I'm pretty sure. So let's just do that. Okay, so we'll do I and then I minus 1. It should actually be I minus 1 and then I. Yeah, there we go. Okay, so those are those. And what would happen here is if let's say this left is negative, let's say, this would break right away, right? So let's say you would return like -1 and 0. So here you would return like like 0 and 0 or something, or 0 and -1. So this would be like a very short string. So this would never be a valid result. Yeah. Okay. And so we do the same thing. So this is literally just copy over here. And now essentially that we got both of those, now we should have the optimal start and end index. So now we can just get that substring. So we can say S, starts at start and ends at n plus 1, because remember this is non-inclusive, so it will actually end at end. And that should be it. So let's take a look. See what the error we have is. Expand from center. Oh, right. Okay. There we go. Same thing. Let's copy this. And there we go. And this is like kind of the easiest way to do these problems. You just build palindromes out for the center instead of doing some kind of DP or something. And we have a pretty efficient solution. So here for the time, this is going to be O of n squared, right? You have 2n starting locations, and then for each one you have to build that all the way. So every expansion takes n time, and then we also have a loop that goes 1 to n, so time O of n squared. And space is going to be O1 because we didn't store strings, right? When we didn't append to strings, we instead use indices, which is going to be a lot better in almost all these problems. So definitely get used to that for doing these problems. Instead of appending to strings and storing strings, just store indices, and you can always figure out the length of a string by the start and an index. That way you're not like building the strings and you have O1 operations. Because building the strings would be really not good, because you would have, like, let's say you have a string like this, you would be adding a letter to the left and a letter to the right, which you know, takes the length of the string, and then every time you add a new letter, you're rebuilding the entire string, which is inefficient. So this is much better. And yeah, that's going to be all for this one. So if you like this one, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.